Hi, this is M. Prasad and today we are discussing about the gas chromatography. Chromatography is a major part of the biochemistry. So chromatography to segregation like a separations of migrations of particles by using of charged particles. So by using charge. So like what are the charged particles? Like charged particles means carbohydrates, proteins and vitamins. These are the separation by using chromatography. Also we using like chromatography is major concept here. We're talking about these things. So chromatography using here the different types of chromatographers like gas liquid chromatography and absorption chromatography and high performance liquid chromatography and cellular assisted chromatography. There are different types of chromatography. Coming to that, we are talking about today gas chromatography. So this gas chromatography is refractive injections of distillation. So the next two experiments like introducing gas chromatography and samples of fractional distillations. So they are then tried together along with the reactive indexed and techniques and third experiment. So in this first week, like this week, like a gas chromatography, I stated like a power, like these things. So then second, like a mixture of distillation. Then third, like a gas chromatography, refractive indexing of distillations of the distillations of mixture and experiments. So gas chromatography, what are the uses of gas chromatography here? Gas chromatography uses is separations of analysis of organic components and testing the purity and components and determine the relative amounts of components of mixture and components identification, isolations of pure like compounds that micros work and similar to column like chromatography but they differ from the three ways. So those are the partition process of carried between the moving and stationary liquid phase and like temperature can be controlled. Then also like a concentration in compound like compounds gas phase functions vapor and like pressures only. Gas chromatography is also vapor phase chromatography also and gas liquid chromatography. Gas chromatography is a macro lateral syringe. So what are the requirements? Some like a macrolateral like a microlateral syringe and high like a heated injection port with the rubber sputum and inserting the sample. So heat chamber with the carrier gas to inject port and oven the contain the copper and stainless steels or glass columns. So also column packed with the stationary liquid phase and non-violated liquid and bags or low melting solid phase like boiling hydrocarbon. Silicone oils and wax are polymetric like a polymeric like esters and ether like polymeric esters, ethers and amides. So liquid phase is coated with supported materials. So principles of separations. What are the principles of separation here? So column is selected packed with the liquid phase and installed with the sample injected with the microlateral syringe into the injection port where vaporized mixture into the carrier gas, steam, helium, nitrogen, argon. So sample vapor because of partitionally between the moving gas phase and stationary liquid phase. So the time different compounds in the sample and spent in the vapor phase is a functions of their vapor pressure. So the more violated and low boiling point and high vapor pressure and compounds arrive at the end of the column with the first phase passed into these things. So like principal detection like a gas chromatography, two detectors here. So thermal conductivity detector it is used for these things and flame ionizations. So thermal conductor detector is electrically heated with the hot wire placed a carrier gas stream. So thermal conductivity is of carrier gas, helium or in our case, the higher than most organic substances. Presence of a sample compounds in gas stream reduced thermal conductivity of stream. So wire heated up and resistance decreases. So two detectors used here. One is exposed to sample gas and another is exposed to reference flow of carrier gas. So detector forms of Wheatstone bridge, so which becomes an unbalanced simple gas. Unbalanced bridges generate the electrical signal which amplified the send to the recorder. So what are the factors affecting to separation? So boiling pointing of boiling points of components in sample. So low boiling point compounds have higher vapor pressures. High boiling point compounds have low vapor pressure and requiring the more energy to reach equilibrium vapor. Example like a atmospheric pressure. So boiling point increases as well as molecular weight is increased. Flow rate is carrier gas, and chief like a choice like a liquid phase. Molecular weight is functionally groups and like polarity components of molecules and factors selecting in the liquid phase. So the length of column and similar compounds requiring to longer column than dissimilar compounds. So isomeric mixture often requires the quite long columns. So the experiment's purpose on introducing theory of technique gas and identifications like chromatography is the components of restrictions of like these things. So from the relationship between the peak area and the molecular content with the calculated molecules. So fractional and mole percent of the component mixture. So how to approach the obtain the chromatography is known as the equimolar mixtures and 4 esters like ethyl, propyl and butyl and hydroxyl esters. Obtained with the chromatography is unknown mixture of the more components and these are things. So determining the retention times, calculating peak areas, calculate the total areas, calculate the mole fractions and calculate the percentages. So the experiment cannot be so these things. So group work with 3. So each group will be like same standard is the chromatography and each student will be their own. So sample of standards these 4 esters like ethyl ester, acyl ester, propyl ester and butyl ester and hydroxyl ester. They are known for 1 to 4 compounds of in standards. So finally this called the chromatography instrument setting the processing this sample to get a chromatogram is considered one procedure, and the sample multiple samples some subsamples are processed with the same procedure. It is not necessary but step up a separate procedure to each sample. So this process is obtained gas chromatography is known as a mixture of 4 states known as a mixture utilizes the 4 samples. The summarizely we will talking about the like these things. So result like a experiment of logical organization like these things. So conclusion to gas chromatography state is the experiment must present in the arguments using applications results and supporting the identifications of components and unknown mixture. The unknown mixture is the equivalent mixture. The 4 states the component on the equivalent peak areas known as mixtures and applications of thermal response corrections and factors. The adjacent peak areas of compounds of mole percent of unknown mixtures. So recording instruments like injection port temperature and column temperature, detector and gas flow and chip and injecting the sample. So the sample injector, the B part of the microcylinder fragile expensive and be careful like a mark starting point and on the chart on vertical line. Insert the needle fully into rubber and septum. So until the resistance and maybe 1/4 position inches remains. So inject the quickly remove the needle. So start the recorder simultaneously with the sample injections. So determines how the retention of time the period is following injection that required for the components of to pass through the column and point there where the detector is current mixture or maximum pen and deflections of maximum peak light. So for a given set of constant conditions carrier gas or flow rate carrier gas like a column temperature and column length and liquid phase and inject port with the temperature and the retention of time like any compounds is always constant. Retention time is similar to the retarding factors in thin layer chromatography. The components retention time from the chart speed 5 centimeters like minimum. So distance is the one of the chart from the time injection the point with the chart with like a perpendicular line drawn from the peak highest interest in the baselines. So that is the quantitative analysis. Coming to the quantitative analysis, the area is graphic chromatography is proportional to the amount of molecules of the compounds of eluted, and the molar percentage compositions of mixture can be approximated by comparing the relative areas peak in the chromatograph. So this approach assumes the detector is equally sensitive to all components and it is responsive linear, and these components assumes usually linear decrease the response adjusted. Thank you.